Okay, so we are going to talk about a whole bunch of things. So I've got a project called animals. So we're going to do some stuff with animals. I'm going to make a package. Okay, there's an issue. And there's screaming animals outside. For what I'm going to do, it's best to do a package. It's always a good practice to do packages anyways. And remember, the package should be the reverse domain name. So we're in bcit.ca. Comp 2526 is the course. That should lead us to a fairly unique identifier. I'm just going to make a new class. Actually, going to make an interface, and I'm going to call it animal. So this is going to be a somewhat long video, and it's going to cover a whole bunch of things. So what I want to do is try and make things as abstract as possible. To make them as abstract as possible, I generally deal with interfaces. This is on the JUnit video. It's not always the case that we're going to make interfaces, but it's not a bad idea. And quite often what you'll do, and we'll make use of that interface later, but quite often what you'll do is make an abstract class that implements that interface. Oh, sorry. Naming is important. Some people would call that I animal, I for interface. I hate that. What happens if I change it to an abstract class later on? Well, now I makes no sense, and I can't change it because once you've set up a name and made it public, you're kind of stuck with it. So I don't like to encode things in my names. People do that in fields as well, variables, like I whatever for integer. That practice ultimately comes from Windows, as far as I'm aware. I could be wrong, but that's where I'm aware. That's where it was claimed to have come from, and it's called Hungarian notation. I think the guy who created it was Hungarian, and it was useful back when we didn't have help and things like that. But it's a horrible practice, because what happens if I change that variable to no longer be an int, for example, right? It's just you wind up with all these things when you name things specially. So don't try to encode information into a name. Abstract animal, okay, it's an abstract class. I don't have a better name for that, and I can't call it animal. So I'm kind of stuck with the word abstract. And if it became a non-abstract class, it's a minor confusion. It's not a huge issue. It's not like, oh, I thought this was an int and now it's a string. Okay. So we need something that all animals can do. Well, all animals have a get name. So it's an interface. I don't have to declare things as public. I can just make it a string, get name. And I guess I also have a number of legs, right? Like a snake has no legs, a bird has 2 legs, dogs and cats have 4 legs, barring unfortunate accidents or birth defects. So let's go with so the question before was, what should I use? Is a byte a reasonable size to represent the number of legs of something? Like an int is 32 bits. That's 4 billion values. A byte is only 8 bits, 256 values. Do we reasonably expect things to have more than a byte's worth of legs? However, in Java and in other languages, if you choose something other than int, it winds up being a bit of a pain. And in reality, inside the VM, everything winds up being a 32-bit value. So there's some tricks you can do around that. So kind of int is just the standard thing if you're counting things. And I may as well have it just speak. And give it something to say, right? We want it to say hello. So maybe some animals can say different words, like we can. Birds have different songs, all that kind of stuff. So there we go. The abstract animal, it doesn't have to override anything because it's abstract, but there are these three methods. So depending on your IDE, you've got some ways to deal with this. So we can go to generate, and we can say we want to implement methods. And okay, getting the name and the number of legs, those are actually pretty straightforward. We can make that as high up the hierarchy as we want, and we can put that in here. Speaking is different because everything speaks different. A cat meows, a dog goes woof. So realistically, we want a name. I usually make my variables final unless they're going to change. And now I have to ask myself, do I think that this value will change? So can we change somebody's name over time? We actually can. So we should also in here have a void set name method. Technically, you could cut off someone's leg. You could do whatever. We're just going to say legs can't change. You've got 2 legs. You've stuck with 2 legs. It's complaining here because I haven't given it a value and it's final. So that tells me I need a constructor. Because it's an abstract class, I can make the constructor protected. And I don't know how many legs we're going to take. When I don't know something, I have to pass it in as a parameter. Realistically, you probably want to make sure the thing has a name to begin with. But let's say we don't know what the name is. We want to be able to say you have a name or you don't have a name. So now we've got this problem where we've got the same constructor, 2 constructors doing the same thing. So I'm going to call this, passing in a name, and numLegs. And I just want to flag this as unnamed so we don't forget, right? So by default, we're going to say something's unnamed. We could call everything Bob, I don't know. Yeah, by default, it's unnamed. Otherwise, they pass in a name. So the name... it doesn't matter what order you do these things in. I generally assign them based on the parameter order. Right? Or depending on if there's a whole bunch of work to do. And I do like to line things up. So we can return, pardon me, we can return the name. We can return the number of legs. And while number of legs is hard-coded, or not hard-coded, it's final, we can't change it. We could override the getNumberOfLegs method to return a different number. So say we knew somebody had an amputation, we could record that in a lower class. It kind of sucks, but you can get around this restriction of it's a final variable. If we found out we wanted to be able to modify people's number of legs that people have or animals have, we just wouldn't make that final. I just want to be able to talk about final. I also tend to do things in the order that I put them in here, so set name goes first. Now, I'm not doing any error checking yet. We're going to get to that. And I'm not going to unit test this. You've seen the unit testing thing. I will leave that to you to work out, but it's straightforward. So it's kind of left as an exercise to you. I can go back and retroactively do it just so I can post it at some point in time, so you can see what I came up with. So now, All animals have names. All animals have a number of legs. We can make sure we set the number of legs in the name. We can change the name. We can get the name. We can get the number of legs. All that's code that when we make a cat, for example, we don't have to worry about that. So let's go ahead and make a cat. Now it's going to extend abstract animal, and it's unhappy because two things. It doesn't have any constructors, so it can't call. It's trying to call super like that, right? But in abstract animal, there is no constructor that takes no arguments. So we have to provide arguments. Now we could mirror it. Like that. And we could be able to give it a name right away too. Now I don't have this call this. I call a super because otherwise I'd have to duplicate the code in here for the unnamed. If I didn't, if I wanted to change it to be like unnamed cat, I could do that by calling this and call like that. I don't want to do that though. I just want to use the super behavior. I want everything to be unnamed if we didn't give it a name. Now it's still unhappy, and if you think back, that's because the abstract animal overrode 3 methods, but the animal said there were 4, so we didn't override speak. You don't need to make methods or variables parameters final in the interface, but I do it in here. Any of the actual code, anything that actually has code, I mark the parameters as final. Again, you don't need to mark them as final, but it's really useful because it stops you from accidentally modifying the parameter. So cats, however, only know how to meow. They don't know what to do with that message. We'll make the dog a little more interesting. Okay, so that's cool. Let's make a new main class. Ooh, forgot to give the cat number of legs. Okay, so here's another thing you can do with constructors. It's silly to always pass a number of legs to a cat because cats always by default have 4 legs, right? So we should probably add another constructor here that calls it with nothing and calls this, passing in 4. So by default, all our cats have 4 legs, but we could choose to provide a different number of legs, right? So now that works. So I could provide a 5-legged cat. I could provide a 1-legged cat, but we'll just go with cats have 4 legs. So now I can run this, and what should happen is it should go meow. Oh, it's not system.println. It does the system.println. Sorry. And it should be animal. I'm not infallible. We can also say system out cat.get, sorry, animal.get name. And animal.get number of legs, just to see what it prints out. So it should print out hello, unknown, or unnamed, sorry, and 4. And it did the meow, it did unnamed it. In our cat, our cat, I did printf, not println. Try that again. So it said meow, it has no name, and it's got 4. So if we come in here And go to cat, or our main, and we're going to call it kitty. Now, why is that not working? So that's not working because we have a constructor that takes nothing, we have a constructor that takes a number of legs, and we have a constructor that takes a name. So we could do one more constructor if we really wanted to, which is a string, which is the name, and 4. And if we're going to call super name and 4, it's the same as calling this name and 4, right? So we have a constructor where you just pass it nothing. You get a cat with no name and 4 legs, a cat with a name and 4 legs, a cat with no name and how many legs you passed it, and a cat with the name and the legs that you passed in. So sometimes you will wind up with many constructors. Generally speaking, I like to have one constructor. But if I'm going to have more than one constructor, I like to make sure that they generally all call the same constructor. Or at least do no work. So these two don't call the same constructor, right? It's not like this isn't the only one calling super. But this one and this one are doing the appropriate thing from that point of view. So let's try now, and it should print out that it's meow kitty 4. And we can give it 3 legs because something bad happened. And now it's got 3 legs. Okay. We keep with a 4-legged cat. So that's cool. Let's change it slightly just to show off some polymorphism. Okay, so now our code is abstracted a bit. If we just see this piece of code, we don't know what it's going to be. Is it going to be a cat? Is it going to be a dog or whatever? Because we don't know what all the subclasses are. And we can do that by, that should have been copy, not cut. Do that by making a dog. And I said we make the dog more interesting, but not yet. I hate how it does this by default. Need to turn that off. So dogs also have 4 legs. They go woof instead. So in our main, we can return a cat. Or we can return a dog. And this code didn't care at all, right? We could return a bird. We could return an elephant. It doesn't matter. The create animal does whatever the create animal is going to do. So now we wind up with, well, I want to be able to control what kind of animal gets created, but I don't want to have it in here. So I'm actually going to make it so that we can pass on the command line the name of the animal to create. In order to do that, I'm going to have to go to this edit configurations. If you're using something else, you'll have to find out how to pass command line arguments. And in our case, the program argument is cat, because we want to create a cat. And then final string animal type. For now, we're going to ignore it. We said pass in a cat, but we're going to return a dog. But we'll print out the animal type just to make sure it's getting cat. So now when we run it, it's going to pass in that command line argument. We passed in a cat. We created a dog, though. So now we need to do this if statement. If animal type equals cat. Yeah, I'm making a mistake. I'm doing it on purpose. Return a new cat, otherwise return a new dog. So let's see what happens. It returned a dog even though we passed in cat, right? Animal type is cat. We saw that before. Equals doesn't work that way. You have to use the dot equals method. And then it works. See? Yeah. One thing, we should probably have an else if, and this is what you used to have to write, which means there must be a better way to do it now. For now, I'm just going to return null. So meow, if we change this to be a dog, it should print out woof. And if we change this to be a bird, it should crash. Because we got a null pointer exception. All right. So now there's a number of things wrong with this. First off, I said there's a better way to do this. So we can, that's the old way. The new way is actually, it used to be that switch only worked on primitive types. Now it works on other things. So we want to switch on the animal type. And by now, I mean in the last several years. First off, I always put these in. It's a habit I have from C++, but I like to do it just because it makes me happy. No other real reason for it. Okay, so here we've got our cat or dog and all that fun stuff. It'll still crash though because we're still not handling bird. So it didn't do any better there. But we simplified that if statement. And we're going to learn a much better way to do this soon, but not yet. We don't need this if or switch statement at all. However, I don't like this because it has multiple return values. So what I do is I make what's called a blank final. So what a blank final is, it's a final variable that doesn't yet have a value. Right? It's the same as in the abstract animal, where this one is told we're going to set the number of legs, and in order to do that, we have to set it in the constructor. If we don't, it's going to be an error because it says you told me you were going to set this while you were creating me, and you didn't. So we got a blank final. So we can say animal is assigned new cat. Animal is assigned new dog. Big thing people forget, especially depending on which language you're using. Now, this is a benefit because I used final. And what's happening is, depending on the language, so C# is different, Swift is different, but C++ and Java, unless I've changed C++, which I can't imagine, C, Java, all work the same way. It does what's called a fall through. So it does the animal is assigned whatever, and then it continues on to the dog case. And because I made this final, it's saying, hey, you told me you're going to assign this once, and you're assigning it twice. Awesome. So if I didn't make this final, it would cause problems. But we need to put in a break, and that tells it to leave the case. You should be totally familiar with break. And then animal is assigned null. You don't have to have a break in the default case. You can if you want. And then we're going to return animal. Okay, so I didn't like having multiple returns. Now we only have a single return. It's still going to crash because we're still passing in bird. And that means the animal is null, and then we're saying null.speak, and that crashes. And this is also why I only do one thing per line, because I only have one dot per line, and therefore, or for the most part, obviously this has more. So I know that when we get the null pointer exception, it has to be animal that's null. So it saves me some time debugging things. So I should actually throw an exception. So I could throw in a legal argument exception and say that animal type is not recognized. And if I do that, it's still going to crash. It's going to tell us that bird is not recognized. Now, remember what an illegal argument exception is. It's an unchecked exception. That's why the compiler hasn't made us deal with it at all. So it's an unchecked exception, which means that the programmer made a mistake. Well, yes, I'm the programmer, and yes, I chose to run it with the wrong argument, but once I'm running it, I'm no longer the programmer, I'm just a user. So imagine this is your pacemaker, or the fictitious pacemaker. You just caused it to crash, right? We do not want it to crash. So we're going to change this. We're going to actually use a exception. So we're going to call it an invalid animal exception. And we're going to make it extends exception. I'm so lazy I don't even type. Now, super typically gets a message, which is usually a string. So we actually want to say that it's the thing that was passed in, the animal type. I'm actually just going to call this ty. So this will tell us, and I can even put it in quotes, this will tell us that, bird, in quotes, is not a recognized animal. And I'm actually going to go a little further than that. I'm going to say type is assigned to y. Now what's type? Well, type is a private final string type. And I can also remember, you've got this generate getter. I hate how it puts it at the top. Again, I should look and see if you can configure that because it really annoys me. I also don't like those on their separate line. They're on the same line. But whichever. So remember, the exception is for the programmer. You can get that message, but sometimes you may want to build your own message, in which case it's useful to know what the problem was. So passing in any appropriate parameters and saving them into variables and providing get methods allows us to do that. So now I'm going to go to main, and I'm going to say that this doesn't throw that. It throws a new invalid animal exception, which requires you pass in a type, the animal type. Okay, why doesn't this compile, right? It should compile. We're doing the right thing. Invalid animal exception extends from exception. Exception is a checked exception. It's used to indicate that you want the programmer to do something at compile time. And the problem is we are not catching the exception. So we have two choices. We can surround this whole thing with a try catch, or we can say the method throws it. It is incredibly bad practice to catch the exception inside of the method that you're throwing it from. That's called basically that's a substitute for something called goto, which is not a great language feature of things. So we're not going to do that, right? If you throw it, you don't catch it in the same method. So we're going to say that this throws an invalid animal exception. This announces to the world that, hey, if you call create animal with the wrong kind of animal, it's going to throw an exception and you're going to have to deal with it. And you'll see here that we have to deal with it. Now there's two ways we can deal with it. We could just do this. Let's see what happens if we do this. We can just say, okay, well, I don't know what to do. I'm just going to throw it. Run it. And we crash. With bird is not a recognized animal. So awesome, our exception is being used. Sucks because you just killed the person who had the pacemaker because our program crashed. So we're not going to do that. Main should never throw an exception unless you're just hacking it out really quick to get things to work. So instead what we're going to do is we're going to do a try block. And we're going to catch. get the message. Bird is not a recognized animal, but it didn't crash, right? So I can even, to be really clear that that's what's happening, it's like, oops. Now we run it, it'll just print out oops. Nobody knows that there was an exception, only we know it, right? So that's kind of the bare minimum, the bare minimum you want to do is print stack trace. If this is all you do, it's bad. But your program didn't crash. It continued running with an exit code of 0, and you got to see where the mistake was. Not great. You want to actually print out a message, okay? So we'll print out that one. So that's cool. And this is a very common pattern of doing things. But often what we'll do is we'll move that into a different class. And we'll call that a factory. And again, I'm going to make that an interface. And I want to steal the name that I already had, actually. So it is basically this. So it's not static. It returns an animal, takes an animal type, and throws the exception. And then I'm going to make a default. Animal factory. And that is going to implement animal factory. And I'm going to implement methods. And all I'm going to do is I'm going to go back to main and I'm going to rip off this entire code. Yay. Coolness. And I'm going to get rid of this. And now I need that animal factory. Right, so we've got our animal factory. We made it the default animal factory, and we now ask the animal factory to do the create animal. Where this really comes into play, it doesn't work out so obviously in this method, but if you pass that animal factory around, now you've divorced completely the idea of creating something. From the rest of your code. So I'm actually going to make another animal factory. This one's fun. And we make it a random animal factory. So this will give us a number between 0 and 100. 0 and 99, I believe. So we're going to do right, so we're going to get a random number between 1 and 100. And then if the number is greater than 33, going to create a cat. Else. I'm going to create a new dog, and then we're going to return it. So we have a 33% chance of, okay, we can do this, less than or equal to 66. So a 66% chance to create a cat and a 33% chance to create a dog. We also don't need to throw this exception anymore because this one doesn't throw an exception. It always returns a cat or a dog. So now if we go into main, notice that we are, in our random one, we're no longer using the animal type at all. Right? It's ignored, which isn't right. So not the best use of this. So I haven't come up with a good abstraction, but that's okay. The point is here that I want to show the factory. So in main, I'm going to create this as a new random animal factory. And this is really important. Notice that I didn't have to change the declaration here. It's an animal factory, which means it can take any kind of animal factory. So if I had initially had this as a default animal factory, when I made this change, I'd have to change it in both places. I want to change as few things as possible. So I'm creating these abstractions so I can use them. So let's go ahead and run this. And odds are we'll get a cat. No, we'll get a dog. This one should be a cat. So it's just unlucky that we got 2 dogs in a row. Not unlucky, I like dogs, but we should get, in general, more cats than dogs. Now, we could get tired of running that. We could do it in a for loop, whatever. But you can see it's creating more cats than dogs. So that's the idea of the animal factory. Now, the way that animals get created is completely removed from our program. We don't know from this how what it's going to get created. So let's go back to the default. So this program has no idea what's going to get created because it doesn't know if it's creating a cat or a dog because that depends on what the user passed in, right? The user could have passed in bird, right? So I'm going to do another animal factory. I'm going to show you that reflection stuff. Now, there's newer ways to do what we do in reflection, but I'm going to stick with this just because it's what I'm used to, and it's quicker from the point of view of I don't have to look up a bunch of stuff, and it gets you the same effect. So I'm going to get rid of all of this. So what I need to do is I need to make a final class of type animal. Now this is using generics, these angle bracket things, and we'll talk about that later on in the course. So animal class is assigned class for name. So there's a class called class. There's the class, and it's got a method for name, and we're going to give it ca.bcit.comp2526.animal type. So it's got to exist in that package. That's fine. So for name could throw a class not found exception. And this time I'm going to do this surrounding with try and catch. And I'm also going to move that. I would like to move my variables in as close as possible to where they're being used to minimize the scope. For now, we're just going to print out the exception, but that's not what we're going to leave it as. In Java, you're supposed to avoid casting. That is the whole point, especially with generics, but in this one case, I have to do the cast. I don't like to do casting, but it's going to be, and this is why there's the newer stuff. So it's just we're just gonna live with this warning for now. I might do another lecture on the newer reflection stuff, but reflection really is beyond the scope of the course. I just want to show it to you. So we've got our animal class, and now we can get the constructor from it, and I want the constructor that takes no arguments. Now the constructor has an issue here. Again, it's a need to add the catch clause because it might have a no such method exception. Now it's complaining here because we've got two exceptions where the body is exactly the same. And there's a special way to deal with that. I will show it to you, and then I'm not going to use it. So you can actually say, I catch these two exceptions or more, that's the pipe symbol, and they're going to be handled the same way. I don't know for sure that I'm going to handle them the same way, so I'm going to not do that for now. So we need to be able to get the constructor, so that's a final constructor for animal. And that comes from the Javalang reflect package. And now I'm going to do a new instance. Now, again, things can go wrong here. So we have an illegal access exception, which means you're trying to call something that's not public to you or not available for you to call. You don't have permission. The instantiation exception, I think, was there was a it had an exception thrown, and the invocation target exception, off the top of my head, I don't remember what it means. We can look those up, but not right now. So we're creating a new instance, and that will be again, I am actually really picky, and I like to line things up. So this is good so far. We got the name, the bird or whatever we're going to create, right? We got the constructor that takes no arguments, and we created a new instance with it. Say we gotten we want to get the constructor that takes a string class, and we wanted to pass it a name. We'd do it like that. And so we create the instance, and then we return the instance. So that's awesome. You'll notice here that my code doesn't reference the name. Like, there's no switch statement, there's no if statement. I don't know about birds or cats or anything. This code has zero idea what it's actually creating. All it has to do is implement the animal interface. So the question is, how am I going to deal with the exceptions? So really what's going to happen is I'm going to throw a new invalid animal exception. And I'm going to pass in the animal type, but I also want to say, actually that's fine for this one. It's unhappy because we don't have the throws up here. So that's fine. So I want to actually go back to the invalid animal exception and add two things. So what I'm going to say is bird has no whatever, right? So bird has no argument constructor. That the constructor is inaccessible. I don't know what the issue is here. And I don't know what the issue is here. We have to figure that out. But I'll put in a different message for them right now. And there's another thing we might want to do quite often with these things is actually pass in the exception that caused it. So I'll do it for a couple of them. I'd probably do it for all of them, but I'm just going to do it for a couple. So that's the got a null exception. So there's another. So this is something I forgot to mention. You use throwable in this context. I said never use throwable. This is the context where you'd actually use throwable. Because you don't know what kind of exception it is. Also, I tend to do this. And again, I line them up. The reason I do all that lining up and everything is it's like reading. Your eyes are drawn to a difference. So here I can see everything's lined up. I can kind of just forget about them. I know this whole blob here is just... that whole blob there is not interesting. It's just the arguments and all that. If I care about the arguments, I'll look at it. If not, I don't need to look at it. I don't have to scroll over to the side of the screen if it gets really long. So I've kind of broken my rule here. I can't fix it completely because these two can't, neither one of these can call each other, but this one can. So this should actually call this. With the type. So at least I can get rid of part of it, right? So this would be like bird is not a recognized animal. And that gets done when we call this one, right? So this would be bird is not a recognized animal. This one will be bird has no NOR constructor. NOR constructor is not accessible. And then these two things that I'm not 100% sure. I just want to check when I'm doing this that I did put a space. Okay, so let's try running this. Oh, I don't think we used the reflecting one. So I want to create this as a reflecting animal factory, reflection animal factory. So bird is not a recognized animal. Cool. Let's go ahead and add a bird. I could just copy dog. Now, I'm not going to show you this because I don't have an easy way to do it, but what I could do is drop to the, well, yeah, I don't have an easy way to do it. I could drop to the command line and just compile the bird class all by itself, not compile anything else. So we've just got bird. Birds have 2 legs. And they go chirp. So I could just compile the bird, nothing else. I could run this program, and with the reflecting thing, it will automatically pick it up. So not able to demo that easily, but pretend that's what happened. Trust me, it works. Now it went chirp. So let's break this. Let's make these constructors private. All right, run it again. Now we know it's not doing any compiling because, or doing anything with the compiler because we made these private. Normally if we're saying new bird, that wouldn't work, but we didn't, so that worked. So what were the other things that could go wrong? Has no org constructor, we can do that too. Just comment this one out. Oh, I think you have to comment out more than that. Right, bird has no org constructor. And then what happens if this throws make it really clear. We'll throw a runtime exception. Remember, runtime exceptions aren't checked, so let's see what happens when we do that. So it did this one. So this means if we go to the reflection animal factory, that this one becomes that it had an error while creating. And that means we can also go to main here, and we can also do get cause. Ignore that. And we can see that it's an invocation target exception was the cause, right? And we could do ex.get cause dot print stack trace and find out the exact line number stuff that happened on. Right? So we find out that there was a runtime exception was thrown from that. So we can go here and go, oh, well, we shouldn't have thrown that. That was a mistake. We're all good again. So that should really show you polymorphism. There's no way that our program, with this one especially, there's no way, because the user's typing in the word bird, and if we look at the reflection animal, there's no reference to bird here whatsoever, right? So this thing doesn't have a clue what it's doing. Yet we're able to create an instance of it, and we're able to successfully call these methods, right? And they're able to behave differently depending on the type that was passed to it. So it's, this is the extreme version of polymorphism our program has no hope of, you cannot look at this program, you can't look at this code and know what it's doing. There's no possibility that you would be able to tell just by looking at the code what it's going to print out. Now, I did say we could make the dog a little more interesting, so to make the dog a bit more interesting, we could do something like this. If message right, so if it's hello, it'll print out woof. If it's goodbye, it'll print out whine. Otherwise, it'll wag its tail. So we can go to main and we can pass in goodbye. And we can make sure that we're creating dog. Right, so it's whining because we did goodbye. Did I miss? Oh, whine, yes. And if I said goodbye with an exclamation point, it won't recognize that, and it should print out wagtail. Right? So you can do things, right? You can do whatever you want inside the methods. They can be as complex as you want them to be. So that covers factories, which is part of the design stuff, right? So the idea that you're going to create interfaces are preferred. Oh, and I did not show you that. So let's say we have a new class. let's say it's a wolf. And let's say for some reason, I'm just going to extend object now, which is fine, and by default that's what it would extend. But let's say for some reason we're extending something and we can't extend abstract animal. So we could change it to be implements wolf, implements animal. So the class that we're extending doesn't provide all the methods we need, but we can implement animal, and we can return the name. Actually, so at this point in time, we may as well, for simplicity's sake, just go to the abstract animal and copy everything. Oh, and I'm missing speak. So by default, wolves have 4 legs. And they howl. And see, it says wolf is never being used, and that's fine. We're going to come into our configurations and we're going to put in wolf, and we're going to run the program again. Now remember, we could do this with only compiling the wolf class, and we run it, and wolf has no nor constructor. Oh, it's that's weird. Shouldn't have anything to do with the protected thing, but let's see. There we go. So was that protected that caused that? Okay, so there is one thing in reflection. Normally you're only dealing with the public stuff, but so where I did the get constructor, you can do get declared constructor. So get constructor, I assume this is right. I've done it for methods and never paid attention to constructors. Getting the declared constructor will return all of the constructors. Getting constructor will only return the public ones. So I think that'll work. So that's what the problem was. And because we're in the same package, the protected thing is fine. But really what I should do is go to wolf and make sure that my constructors are public, because that's what they were supposed to be. So we have the interface animal, and we provide that interface in case a class can't implement that can't extend the abstract class. It can always implement the interface. So that's one thing. The idea then becomes that we only use animal. So when we return values, when we pass values around, we treat them as animal, unless we really need to treat them as a cat or a dog or whatever. So that's the advantage of using the interface. You want to keep things up as high in the hierarchy as you can, which means you don't have to make changes, right? Animal factory, we can change this back to a random or default. Now, the default animal factory is not going to work, right? If we run this, it's going to crash. Not crash. It's going to say that wolf isn't recognized. But wait, wolf was working before. That's because we didn't update our default animal factory to include wolf and bird. And I'm just going to keep them alphabetical. Right, so now we run it, and the default one will pick up the wolf and the bird. Right? So that's another thing. When you make changes, you need to make sure you update all of the stuff. This is also where unit tests come in handy, right? So we would rewrite our unit test to, oh, we're adding a bird. Well, we better add bird to our unit tests. And then we'd realize, oh, we forgot to deal with this factory. So the interfaces let you treat things more abstractly. The default class, or the abstract class, the abstract animal, lets you declare all the things that you think are common inside of there, and do all of that. The factory, again, it's an interface, but what it lets you do is remove the creation from your program. So now we can provide different ways of creating things, and they can return different things, as you saw, right? The reflection one always returned the right thing. The default and the random, well, random right now will only return cats and dogs, no birds, no wolves, right? So you can think about this in terms of a video game, where you're needing to spawn a monster, right? So you could have a thing that randomly spawned an appropriate kind of monster, and you now can just say, okay, any code that needs to spawn a monster can take this factory, and you can pass the factory around rather than have to rewrite all that if-else statements. And sometimes it's really hard to expose a method. It makes the code really brittle, so passing around a class is much more preferred. And then the reflection stuff, right? Where we're able to get the class, get the constructor, use the constructor to create the animal. We can also use that to get, like I said before, we can get methods, we can call the methods, all that kind of stuff. So the only thing we actually are missing is the equality. And I'm going to be lazy, and I'm only going to do cats. And what I'm going to say is that I want to generate certain methods. So one thing that's useful to override is toString. Let's see, we'll do, we actually want to do this in abstract animal. So we're going to generate a toString method. And it's going to use the name and the number of legs. Sure. And that's just probably a very poorly written, from what I would care about, toString method. Now, toString is useful for debugging. Okay, so I once had some code where a table that displays in a UI used the toString method, and I changed my stuff to like, oh, I need to print out some debug information. All of a sudden, a table was filled with all my debug information. That's horrible. Don't do that. Okay, so where that comes in, I'm going to just comment this out for a second, or just delete it for a second. If I come into main and I say animal, what it actually replaces that with is called the animal.toString. Okay, but ignoring that, so we call system.println animal. We run this now, and we're going to get a weird result. It's going to print out this weird thing here. And don't worry about what this is. It's machine specific, VM specific, I believe. But it really is no value to you at all. I think it's a hash of the class of the class file or something like that. So we're going to go back to the abstract animal, and we're going to add the toString. And now no, it should have. Oh, we're creating a wolf. Let me edit the configuration to be a dog. Because remember, wolf doesn't extend from abstract animal, therefore it didn't pick up the toString. So the name is unnamed, and the number of legs is 4. So useful for a debugging thing. I don't like the format of it, but that's fine. We're also going to generate equals in HashCode. So let's see what happens. We want the name and the number of legs to be used for the equals. I'm just seeing how they're dealing with this. Actually, this is horrible. I'm going to do it, but I'm just going to do it to show you. But it is horrible because what we're using is the name for which can change. So my name could be Darcy now, and I change my name to Bob later. I'm no longer equal to myself, but I'm really the same person. So using name is a horrible thing in this case. But the number of legs isn't unique either. Name isn't unique. This is why BCIT gives you each a student ID, why the government gives you a social insurance number, why you have a driver's license number, right? These are all things that the entities themselves, so ICBC or whatever, have created as their, if you think about a database, it's their own primary key. So I'm going to generate this. It's going to be horrible. I'm going to delete it afterwards, but I do want to show you what it looks like. So HashCode, there's this objects.hash, which makes your life super simple. It'll go off and create some number. Remember, all you care about is that the number gets created consistently for two objects that are the same. So that's going to be fine. In this case, this is the one and only time where you should generally use equals equals. It's a shortcut. So when we call the equals method, if we're pointing at if we're saying something like this, if foo dot equals foo, right? So if we did that, well, obviously they're equal. They're the same object, right? So we're saying here, are they the same object? If so, return true. Otherwise, if the other one's null or they don't have the same class, so the get class will tell us if you called it on a cat, it will return cat. If you called it on a dog, it'll return dog. So this is polymorphic, right? It won't return the class of abstract animal. It'll return the class of cat or dog, depending on what you create a new instance of. So if the two classes aren't the same, then return false. I don't know why they're using this here. I would prefer to use the equals method, but I assume that they're doing it right. So I guess there's a guarantee that when you call get class, it always returns the same instance. Probably true. I prefer not to think about those things though. One of my rules is don't make me think. So dot equals would be safer here. And then we take the other object, and you always pass in an object for equals. For the most part, some people will do. You always have to take an object, but you can provide other forms that don't take an object. String has an equals. It takes a string, for example. So you have to cast it to an object, from an object to an abstract animal. So this is casting. We try to avoid it, but if we have to, we will. And then we check to see, do the two legs equal and are the names equal? If they are, they're the same object. Now, obviously that's not true because I can create 100 cats called Fluffy and by default they'll all have 4 legs. So that's clearly not the right way to deal with that. But again, that's not the point. I just wanted to show you how to override equals in HashCode. I'm going to delete this because it's wrong. And then the other one is you can implement. Now, if you want to implement more than one class, or more than one interface, you do this. And we'll probably do it comparable on an animal, I think. So the comparable interface, we want to override the compare to method. So here we could do return name dot compare to o dot get name, that kind of thing. So that will let us sort by name. We're going to touch on comparable and comparators and all that later on in the course, so I don't need to worry about that right now. So I'm going to delete that too. So that's a simple little bit of code that shows you a whole bunch of stuff. There will be more videos to come. Have a good day.